Hello everyone, my name is Narimane Gassa. I am the early stage researcher number 10 in the PersonalizeAF European project. My PhD thesis is entitled Forecasting Atrial Fibrillation, and we are involved in the work package 2, Technologies for Atrial Fibrillation Treatment. I started my PhD thesis the 1st of September 2020 at the University of Bordeaux under the supervision of Drs. Najib Zemzemi and Yves Coudière. We are working together in collaboration with the INRIA Bordeaux Sud-Ouest and the Electrophysiology and Heart Modeling Institute, the LEREC Institute. I have 3 planned secondments from July to October 2021 at EP Solution under the supervision of Alex Kalinin, from November to December 2021 at the University of Valencia under the supervision of Marie Skłodowska, and from September to October 2022 at Simula under the supervision of Christian Valencestadt. As for my side, I came from Tunisia, where I had my university studies, starting from the preparatory school, where I had 2 years of university level courses specializing in math and physics. Then I enrolled in the National Engineering School of Tunis, and I got my engineering diploma back in 2019 in modeling for industry and services, specializing in scientific computing. Now I'll move on to my PhD thesis, and I will give you a quick overview on my research project. I will start with the hypothesis. Clinicians assume that the anatomical structures and the anatomical details in the heart play an important role in atrial fibrillation. From this, we can hypothesize that these anatomical triggers can be identified using the non-invasive ECG methods. In fact, cardiac ablation techniques is often used in case of heart arrhythmia. Cardiac catheters are introduced in the heart in order to identify the regions to ablate. This is an invasive method with risk of complications. An alternative procedure is the non-invasive ECG, where we aim to reconstruct the electrical activity inside the heart from the body surface potential. This is, of course, a non-invasive method, but the results remain not very satisfactory. One of the approaches to solve the ECG inverse problem would be to use the clinical patient data, so the MRI or the CT scans, and the signals at the body surface to personalize the main parameters of the cardiac electrophysiology model. In our research project, we aim to design a cardiac electrophysiology model that is suitable for clinical use and that describes the heart arrhythmia accurately. And in our future work, we aim to personalize this model in order to provide a new electrocardiography imaging tool, especially in atrial fibrillation conditions. There is still a way to go, and I will keep you updated in the next videos. Thank you very much for listening, and thank you for your attention.